Hi again, and welcome to this Me vs Maths tutorial, which is about using trigonometry to find missing angles in right-angled triangles. This is tutorial 4 in our series on trig, so if you've got some catching up to do first, then please do that. Otherwise, let's get this show on the road. Hopefully the trig formulas are starting to look really familiar to you by now. In fact, you're probably getting a bit sick of them, but hey, you've probably started to memorise them, so it's all good. Just before we get going properly, for this tutorial we're going to be using what are known as the inverse trig functions. These look like sin -1, cos -1, tan -1, and so on. On a calculator, these are normally accessed by pressing Shift or sometimes second F and then the sin, cos or tan buttons. It's often similar if you're using a calculator on your phone, tablet or other device too, or sometimes they can actually have their own button on those sorts of devices. So check that you know where to find those three functions. This question then is asking us to find a missing angle. Apart from that fact, it looks fairly similar to the sorts of questions we were looking at in our previous tutorial. And most of our actions are actually going to be exactly the same as they were when we were finding a side. So step 1, as previously, label your sides first. Now the next step is to identify what I've been referring to as the active sides in our triangle. Previously, one of these was a side which we were given and one was a side that we were looking for. This time we have been given two side lengths, so these are our two active sides. Let's tick them. So we're looking for the formula that uses the opposite and adjacent, which is TOA. Still, just as before again, let's now write our formula out in full. Let's substitute our values in 2. We don't know the angle, but it is called x in our question, so I'm going to replace the theta with an x. Now, always be really careful that you get the next two numbers the right way around. The opposite should be on top, so it's 8.6 divided by the adjacent 9.9. Now we have tan x and we just want x, so what we actually have to do now is to cancel out tan. To do this we have to use the inverse of tan, or tan -1, which I spoke about previously, finding on your calculator. So x is actually equal to inverse tan of 8.6 divided by 9.9. Again, this is the value of a good dedicated calculator. If you've got one, you can enter everything on the right hand side now in one go. Use the fraction button if you wish, and just as before, you'll get an answer. We need to round it off. Ultimately, we get 41.0 degrees. Let's look at just one more example. As before, let's label our sides and identify the two active sides. And as we know for angles, this is the two sides we've been given. We're going to be using cos, as that uses the adjacent and the hypotenuse. Always write the formula out in full. It just helps make sure everything is substituted into the right place. So cos theta is equal to adjacent over hypotenuse. So cos y is equal to 3.8 over 12.4. The adjacent on the top, the hypotenuse on the bottom. To get y on its own, we have to get rid of that cos, so we need to use the inverse of cos, or cos -1. So y is going to be equal to inverse cos of 3.8 over 12.4. As before, get a good calculator where you can enter all this in one go, get an answer, and round it off to give 72.2 degrees. Okay, that's angles done, and that is all the essential parts really of right angle trigonometry. We've got another tutorial where we compare Pythagoras in trigonometry and look at which to use and when. Any questions on anything we've done, then as always just post a comment either on YouTube or at the website at meversusmaths.com and I'll do my best to help. As always, thanks for watching, take care and bye for now.